Okay, good morning. Today, for pre-calculus, I'm going to be looking at the law of sines, special cases with that, as well as the law of cosines. So in the last video, we talked about law of sines, and I introduced that to you. Um, and one of the big things with law of sines is you want to have a side and angle across from each other, where you know both values. What we didn't talk about in the last video was if you have either a triangle where you have two sides and an angle. This can be a rather unique kind of situation, where you have, we'll call this 20 degrees and this is 5, and then this would be 7, something like that. This would be, where I have the angle and then two sides, ASS. When I teach geometry, I tell my students there's no ASS when you're proving triangles congruent, which could also be called SSA, which is probably a little bit easier to get on to. You get in less trouble for saying SSA than ASS for obvious reasons. So anyway, if you have that situation, you can have more than one answer, is what it boils down to. There can be more than one triangle that works out with those values. Which means usually, actually, what it means is there's a triangle that's acute and one that's obtuse. Okay, so one that has an angle bigger than 90 degrees and one that, or all the angles are less than 90. Just a quick refresher. This is the law of sines, where you have the side over the sine of the angle, and you can also flip all three of those upside down. Okay, and if you need a refresher on that, go back to the previous video on law of sines. All right, so anyway, we're going to be looking at that when I have two different triangles. Okay, so the way this works out is this is the first one where I've got I solve the triangle and I have side A, angle A, and side B. So the first thing I do over here is I fill in my triangle. I like to have a diagram, which is always helpful. So once again, look at this. I've got ASS, one angle and the two sides, not the included side either. So for me to solve this, I'm going to go 5 will be B over the sine of B, and A over the sine of angle A, which of course is 58 degrees. So if I set that up like this, and then I cross multiply and solve, I get 4.5, cross multiply, 4.5 times the sine of B equals 4.2402, okay? And then if I divide by 4.5 and do the inverse sign, maybe I'll even fill in that step for you, especially since it's the first one. So I filled in those two steps in case anybody's struggling with how I got from from 4.5 sine of B equals 4.2402 to B all of a sudden magically being 70.4. Make sure you're in degrees, not radians. So if I do that, I got the angle B. Now remember, there's an easy way and a hard way to do these. You could go doing the law of sines again. The easiest way, though, remember, is that 58. A triangle adds up to 180 degrees. So I have two angles plus B equals 180. And if I solve that, oh, I got B. Sorry, that I'm looking for C. Change that B to a C. And if I solve it that way, I get the angle C is 51.6. Okay, so 51.6. And then I can do law of sines with this again, with the 51.6, because I'm missing side C. Remember, when they say solve the triangle, that means you're finding all the values of the triangle. So if I do that out, and I solve it this way, I cross multiply and solve and get C equals 4.2. All right, so there's one of the answers, right? Now, I know that there can be more than one different triangle here. So I've already know that angle A is what it is, but let's say angle B could be two things. Let's say angle B could be obtuse or acute, which means that, we know that the sign is positive in the first two quadrants up there, which means, I take that 70.4 and I subtract it from 180, and I'll find the obtuse angle, that this angle that this triangle also could be, which in this case would be 109.6. So now I know that if angle B is 109.6, I can find angle C really quickly because they add up to 180 degrees, right? So 58 plus 109.6 subtracted from 180 gives me the 12.4, all right? And I'll just fill that in because angle A is still 58 degrees, okay? And now I'm going to find side C, which we'll see will be different than the 4.2 I got on the left because this is a totally different triangle. So now I can go C over 12.4. I'm just going to redraw my diagram over here because this is a different kind of triangle. In fact, I'll probably make it look obtuse. All right, so anyway, there's a quick representation of what the triangle would look like with the obtuse angle, okay? So anyway, I set it up like this, where I can cross multiply and solve. And if I do that, I get 4.5 times the sine of 12.4. And then you're going to get, it would be equal to C times the sine of 58. If I divide by the sine of 58, you'll get this, all right? And then quick division, and I get C equals 1.1, and there's my other triangle, okay? Yep, all right, so there's the other version. All right, next one. This one, let me draw a diagram. A is 60 degrees, side A is 18, side C is 20. So I got to have the sine of 60 and the 18 across from each other in that triangle, or in the setup with the law of sines there, which I have. And then I'm looking for angle C in this one. You could go for angle B just as easily. No, actually you couldn't, because you got to use angle C because the 20 is opposite the angle C. So anyway, if I do that out and I cross multiply and solve, I get sine of C equals 0.962 with some quick division. And then therefore C will be the inverse. So C will be 74.2, that's degrees. Oops, got the wrong thing. Right, and then if I add up the triangle, right, 60 degrees plus 74.2, subtract that from 180, you get 45.8. So there's my two answers for that. Now I need to find the side too, so I'm looking for side B. You'd look at that sometimes and think, oh, gee, it's 60 degrees, therefore it's a 30, 60, 90. But remember, these are not necessarily right triangles, so please don't make that leap. All right, so next I'm going to go, I got B over 45.8 equals 18 over sine of 60. I just reused this ratio up here. And when I cross multiply and solve this out, I'll get side B is 14.9. Okay, now back to the second part, right? We know there's two triangles here, so side angle C could be 74.2, or if I take 180 degrees here and I subtract the 74.2, I get the obtuse angle that it could be, which is 105.8 degrees, okay? So if I do that, I find out, add up that triangle, the one is still 60 degrees. C is obtuse. So this would be your 105.8. And then you'd subtract them from 180 to find out, that B is 14.2 degrees. And then I can set up my ratio to find out what side B is. And if I do this, I get B will be 18 times the sine of 14.2 and over the sine of 60. And if you punch that into your calculator, you will get a nice round even 5.1-ish. Okay. So there's your values that the other triangle will be. Okay. There's number 2. Here's number 3. Another side-side angle one. So two sides are 15, 25, and the angle A is 85, opposite the 15. So I'm going to put the 15 and the 85 in the same triangle. And when I plug in the 25 side, I'm going to figure out what sine of angle B is. All right. And if I do this, I'm going to put another step in here. So I get sine of B when I cross multiply. I'm going to save that 15 for a minute. I mean, you can put it over here. I got 25 times the sine of 85. But then you're going to divide it by the 15 there. So I'm going to erase that. And when you punch all that into your calculator, you get this decimal. 85 sine times 25 divided by 15. I get sine of B equals 1.6603. And then, of course, you'll flip those, do the inverse cosine. Sorry, the inverse sine, excuse me. And when you do that, well, it looks like I do have an extra step there. Do the inverse sine. Don't need that. Yeah, interesting thing happens. When I punch that into my calculator, it says error. Took me off guard for a second. The reason is because the sine, if you remember, is only defined between 1 and -1. So you can't have the inverse sine. What angle? You're asking what angle gives me 1.6? There is none. So that one actually has no solution there, which doesn't come up that often, but once in a while you'll see it. You know, and kind of the reason why this happens is because there's a very, very fundamental thing in geometry where the biggest side of the triangle lies opposite the biggest angle, which means 85 degrees is a large angle, right? In fact, you know, there's only 180 degrees in a triangle, so 85 of those is taking up that one particular angle, which leaves 95 degrees for all the other angles. Now, 25 is a lot bigger than 15, which means angle B has to be a lot bigger than angle A. And there's just not enough degrees in the triangle to work that out. Okay, so that's why this particular problem has no solution. All right, and like I said, it doesn't come up that often, but once in a while you do see it. So just if you get one of those, don't think that you messed up. You might want to go take another look to make sure you didn't mess up. But that's the answer. It's just there's no triangle, no solution. All right, so that was that. Now I'm going to show you law of cosines is the next topic. So there's two different forms for it. There's this one over here, which you use when you have a missing side, okay? Depending on whether you have side A, side B, or side C of the triangle. And then there's this version called the alternative version over here, which is really nice. I didn't find it until a couple years into teaching, where this is the ones you use when you have a missing angle, okay? This is actually the same equation over here, the two versions, standard form. It's just that if I had, for example, missing angle A, and I took this whole equation and I subtracted B squared, subtracted C squared, then added A BC, 2BC, or divided by it, I guess, actually. Anyway, if I solve for A, I would get this version over here on the right. So they're the same equation, just manipulated. That's the long way of short way of what I was trying to say. Okay, so write those down, keep them on your formula sheet, and and then we'll get going. So 4. So they give me this the information. They say A is 30 degrees, B is 10. C is 20. Find the smallest angle. So the first thing I always do is I draw a diagram. I still find that to be incredibly helpful. So if you ever get stuck, please draw a diagram and go from there. You will find that there are two setups for law of cosines. Either Side, angle, side, or side, side, side. These are the kinds you see for law of cosines. A quick reminder that SAS means the included angle, the angle in between those two sides, so it goes just in order. I know it's been a long time, probably since most of you had geometry, but notice how the 30 degrees is between the two sides that I know. That's important, okay? So when I plug in these values, I am going for side A is the one I would like to know, which means I got to put angle A goes over here. That's the important thing. Believe it or not, I actually only usually use one equation out of those three, but like ask me about that in class and I'll show you. So anyway, I'm using the a squared equals b squared plus c squared minus 2bc cosine A. I plug in all those values. A is my unknown, side A, lowercase a. So B is 10, C is 20, and the 30 degrees goes at the end over here on the cosine. Okay, so next I'm going to plug in all those values, all right, and solve it out. All right, so a couple things. I just did out these. So you could probably punch this into most calculators, all right, which should work, all right. So you might want to try that right now. You know, the only thing you might have to do is take the square root at the end there because you're going to get a squared. But the 10 squared plus 20 squared minus 22 times 10 times 20 cosine 30. Usually you can punch that right in, especially into a graphing calculator. If you're not, the one thing you want to, I see that, you know, students make the mistake of is they get down to here and then they subtract the 500 and the 400. You got to do the multiplication first, right, by order of operations. So go cosine of 30 times 400 and then subtract. That's the one mistake I see students make a lot. So just be careful of that. And you should get a 12.4 being side A. Okay. Now I've got side A. And now I do law of sines. Usually I do law of sines over law of cosines. I feel like it's a little faster, but you can do either. So now I can go, I got to find angle C. So I go, angle B I'm going for. You could go for either one. So I went 10 over the sine of B equals 12.4 over the sine of 30, okay? And then I cross multiply and solve that. And I get this. After I cross multiply, which means the sine of B will be 10 times the sine of 30 over 12.4. And when I do that out, B will be 23.8. So now I know that angle A is 30, because that was given. And I can find the other angle, which is angle C, by adding them up and subtracting from 180. And I'll get 126.2, which means the smallest angle is B, because 23.8 is less than 30 and less than 126. So that would be the smallest angle. All right. Next one, number 5. Same directions here. Find the smallest angle. And number 5, angle B is 9 degrees. Side A is 25, and side C is 15. So when I'm setting this up, I'm looking which one do I use? You want to use the one with the angle. All right. I want to find the side opposite the angle is the way I usually set this up. If it's not, when it's side angle side like that. Okay. So keep that in mind. So I'm using the b squared, and I have to use that because this is the angle that I have, all right? So the angle B dictates it. I don't want to use the one with angle A, for example, all right? That just won't work well. All right, so let me write that down. Which means if I go back to the last problem over here, number 4, you'll see that I went for the formula with angle A in it, okay? The cosine of A, and down here, number 5, I'm using angle B, which is the one with a cosine of B, okay? So that's how you choose which formula to use, which is an important thing. So that can be helpful. All right, so I'm looking for angle B. No, I'm not. I'm using the one with angle B, which means I plug in the 9 degrees for B. I got confused from it. All right, so when I plug the numbers in, I get the 25, the 15, 2 times 25 times 15, and the cosine of 9. Okay, and I'm punching that whole thing into my calculator. I'm not usually doing the whole thing out, and when I punch that into my calculator, I get B squared is 109.2. Therefore, I take the square root of 109.2, and I get 10.5 is B. All right. Now, once again, I'm doing law of sines after that. Once I've found now that this side here is 10.5, I can use the law of sines with the sine of 9 over the 10.5 equals, and now I can find angle C. You could also do for angle A, whichever. But when I do this one for C, I set it up this way. Cross multiply. I get the 15 times the sine of 9 equals 10.5 times the sine of C. And therefore, C will be 15 times the sine of 9 over 10.5. And I do the inverse sine for the decimal, and I get angle C is 12.9. Okay, now, the easy thing, right? I got two of the angles. I know the angle C is 12.9. I know the angle B is still 9 degrees, which means angle A, if I add them up and subtract from 180, that's going to be a really big angle, which is going to be 158.1. So the smallest angle will be B. Okay. And I'm done with that problem now. That's a nice thing. So don't go after the sides. You always go after the angle on that one. But I had to find the side in order to get the angle. All right. This time, finding the largest angle. So this is a side setup, right? 1, 2, 3 sides, no angles, okay? Which means I can go for any angle I want. I'm going to go for angle B in this case just because it's the one I pulled out, which means I'm using the cosine of B. And it really doesn't matter which one I go for. Just make sure you label it so you don't confuse the angles. So I plug these values in now, and I'll get that the cosine of B. So A is 7 squared plus C squared is 5 squared minus B squared. B is 10 squared all over 2 times A is 7 and C is 5. All right. So plug those values in, and I can find out what the cosine of B is. So when you take that 7 squared plus 5 squared minus 10 squared, divide by 2 times 7 times 5, you get negative 0.3714, and then do the inverse cosine, right? And you will get your answer of 11.8. All right, now I've got one angle. I got to find a second angle, right? Because I need all three angles. I need to know which one's the largest, which means I'm going to take the cosine of C formula. You could usually easily use the cosine of A formula also, but this is the one I chose. And then I'll plug in the same values, right? The 10, 5, and 7. And when I do that, I get this, 7 squared plus 10 squared minus 5 squared over 2 times 7 times 10. And when I punch that into my calculator and simplify, I get the cosine of C equals 0.8857, and therefore the inverse cosine of 0.8857 is angle C, which would be 27.7 degrees. And now I can add them and subtract up from 180. So angle A plus 111.8 plus 27.7 equals 180. And when I do that, I get angle A is 40.5. So the largest angle is clearly angle B. I probably did more work than I needed to there. A triangle can only have one obtuse angle. So once I saw that the first angle was larger than 90, it would have been safe to stop there. However, I solved the triangle just so you could see a little bit more of that formula in action, okay? All right. Number 7, given side A, B, C. A is 3, B is 5, C is 6. Solve the triangle, and then find the area of the triangle. So we're going to use Heron's formula for finding the area. All right, so I plug in the values. for A, B, and C into my cosine of A formula here. All right. And I get 5 squared plus 6 squared minus 3 squared over 2 times 5 times 6. And when I punch that in my calculator, I get 0.8660. And then I do the inverse cosine of 0.8660. And I get A is 30 degrees. So I got my first angle. Now I need another angle. I'm going to go for B, angle B, all right? So I take the cosine of B formula, which is that A squared plus C squared minus B squared over 2AC. And I plug in the same values, 3, 6, and 5, and I get 0.5556, right, when I divide it out, which means I can do the inverse cosine of 0.5556, which will give me 56.3 degrees. And now I have two angles of a triangle, which means they add up to 180 degrees. So I add the 30 and the 56.3 together, subtract it from 180, and I get angle C is 93.7 degrees. Okay. Now I've solved the triangle. I already had all the sides. Now I have all the angles. Now I need to find the area. Okay, so the Heron's formula is this. Area equals 1/2 AB sine of C. Okay. Which if you look back is kind of like that side angle side thing again. A, B, and sine of C. So your angle is here, and I'm using side A and B. Anyway, that's the setup you use. So I know that the angle C is 93.7. I know that side B is 5 and A is 3. So when I plug those values in, we'll see what we get. So when I punch that into my calculator, I'm getting 7.48. It doesn't tell me whether it's inches, feet, or miles, so I'll just say units squared since it's area. And that's the answer. That's how you find the area of that triangle, right? With that, it's called Heron's formula. All right, that is all I got for today. You guys have a great evening, and if you got any questions, please bring them to class. Thank you very much.